Hello. Hello. Am I audible?
Yes, sir, you are.
Okay. Very, very good evening to all. And now we commit the seminar such as the one-day seminar that will be conducted on the date of 1/4/2022, and the topics such as recent developments in the power sectors. And for that, the above seminar that will be conducted by the SRM Volume Engineering College, Department of Turbine. And now we commit the introduction about our college, and we'll come one by one. Okay. And for that, and here our college, the SRM Engineering College, that was started on the year of 9999, and here we commit the UGC program such as accredited by New Delhi, and the above data that will come around the unannounced Chennai, and our institution should be an autonomous status institution, and the above our college also approved by the ACT New Delhi, and the above should be affiliated to unannounced Chennai, and basically there will be the following 11 undergraduate program and 8 postgraduate program in the SRM Volume Engineering College. And here the Department of Turbine program is duly approved by the ACT and affiliated to unannounced Chennai. And here the department ISO 9001:2015 certified, and the NBO National Board of Accreditation has accredited in the Department of Turbine for last 3 years. And ACT sanctioned there is the 2 modules in the electric machines lab and web-based electronic devices circuit laboratory. And the department also offer the postgraduate program in the branch such as the power systems engineering, and the above was started in the year of 2010. And next, I want to, in this seminar, I want to invite our principal, Dr. Sambarajan sir, and our vice principal, Muran sir, Dr. Muran sir, and our HOD/Triple department, Dr. K. Ilango, Professor/Triple department, and our coordinator such as Dr. Malsuran sir and myself, one of the coordinator. And next, and the today function, that the topic such as the recent developments in the power sector, and the first session that will be handled by Ms.Kousalaya.S.S, Associate Software Engineer, Accenture Private Limited, Bangalore, and the above is the first speaker. And the second speaker, such as the contribution, here the title is the contribution of the renewable energy power sector. And the second speaker, such as the J. Krishnan, Deputy Chief Engineer, Electric Circle, Kasaragod, the Kerala Electricity Board, and he's the second speaker, and he's taking the subject such as e-vehicle part. And the first part, we commit the recent developments in the power sector. The first seminar such as the contribution of the renewable energy in the power sector. And for that, the chief guest introduction that will be given by Rajeshwari, final year Triple student. Okay, I welcome you, Rajeshwari. You may present the session.
Yes, sir. Good evening.
Welcome you.
Good evening, everyone. On this one-day national seminar on recent development in the sector, we have our first speaker, Ms. Kousalaya. Ms. Kousalaya is an alumni of our college. Today, she is here to deliver a presentation on the topic contribution of renewable energy in power sector. Ms. Kousalaya is currently working as an associate software engineer at Accenture Private Solutions, Bangalore. Now, I request Ms. Kousalaya to take over the session.
Thank you, Rajeshwari. Hello, everyone. Hi, sir. Hi, ma'am. Good evening to everyone. So I'm very glad to present this session in front of all my staffs, and I'm happy enough to present this guest lecture on contribution of renewable energy in power sector. So without any delay, let me share my screen. Please let me know if my screen is visible.
Yeah.
Okay. Okay, so now we are going to see about the contribution of renewable energy in power sector. So basically, we all know what is meant by renewable energy, right? Like energy from a source that is not depleted when used. For example, we have many renewable energy sources like wind, solar, and tides, rain, waves, etc. Geothermal heat, etc. We have everything. So basically, the renewable energy is the energy from the source that is not depleted when used. So it is a natural thing, and why it is required, why renewable energy is required is very much important. So basically, we have non-renewable energy like oil, coal, natural gas, and nuclear energy. So when we can produce, we can get power with all these non-renewable energy. Then why do we need this renewable energy? Why it is required? Because coal, natural gas, and petroleum are formed over thousands of years from the buried remains of sea plants, animals, and endecayed organisms that lived millions of years ago. And it also causes many types of pollutions. So to avoid these things, to avoid these types of pollutions, to generate the energy that produce no greenhouse gas. So basically, it should be an economic friendly. So the power demand is very high. The power generated through these non-renewable energy the process may be very harmful to the mankind also. So to make it very eco-friendly, we require renewable energy. So these are the types of the renewable energy. As we all know, solar, hydro, wind, tidal, geothermal, and biomass. So solar is nothing but the light energy is converted into electricity, and by thereby hydropower. Hydropower is also the water power. Hydropower plants capture the energy of falling water to generate the electricity, and then comes the wind energy, and then comes the wind energy, that which is nothing but the mostly the use of the wind turbines. They use the wind turbines to generate the electricity. And then the tidal energy is a form of power produced by the natural rise and fall of the tides, and it is caused by the gravitational interaction between the what we can say earth and the sun and the moon also. So that is what the tidal energy is. And then the geothermal. So geothermal energy, in the name itself we have the meaning. So geo means earth, and the thermal means heat. So geothermal is nothing but the heat within the earth. This renewable energy source is it is used to geothermal power plants use steam to produce the electricity. So that is what the geothermal. And then comes the biomass. So biomass is nothing but the energy generated or produced by the living or once living organisms. uh, what can we say, like biomass fuels, for example, we can say wood, crops, manure, something we can say like that. So basically, wood is the main source and the first source which has been derived as an renewable energy. Now, these are the types of the renewable energy, as we all know. But what uh, but we don't know like which of the renewable energy source has first derived or first occurred or first invented. So we may think, okay, solar or wind or biomass may be the first renewable energy to be discovered, but hydropower is the first renewable energy to be discovered. We all know, right? Hydropower is it is like mechanical energy flowing from water to generate the electricity. So basically, this hydropower is like what we have. A turbine converts the kinetic energy of the falling water into a mechanical energy. Then a generator converts the mechanical energy from the turbine into electrical energy. So this is the basic process of the hydropower. Actually, here the water is stored in the pressure form, and it can only be converted as an other source. So in case of emergency, we can use the pumped storage of water also. So no content of water is damaged or no or reconverted also. So it doesn't change its behavior basically. So we can do it in miniature level also. It is green power, eco-friendly, and it also gives 85% of efficiency. Generation cost is low as compared to other renewable energy production. So hydropower and renewable energy is the first renewable energy to be discovered. Okay. Now, here comes the solar energy. As we all know, what is solar energy? The light energy is converted into electricity. So the process is like solar energy is created by nuclear fusion that takes place in the sun. So fusion occurs when protons of hydrogen atoms violently collide in the sun's core and fuse to create a helium atom. This process is known as proton-proton chain reaction, as we all know, right? So it emits enormous amount of energy. Thus, the solar radiation may be converted directly into electricity by the solar cells. And so this is a function of the solar energy, as we all know. So the contribution of solar energy in the power sector. So recently, in the Ministry of the New and Renewable Energy has reported that in India, the Rajasthan has topped in the install of capacity of solar energy with 7737.95 megawatt. And also, the countries installed solar, the whole countries, the whole India's installed solar power capacity was about 39,083 megawatt as of 2021 report. And in Tamil Nadu, basically, uh, uh, we can say the solar city as Coimbatore, because in Coimbatore now, as reported in the last year 2021, so solar city is Coimbatore. As in Coimbatore, they in many places they are using the only the solar cells, solar water heaters in many industries, in schools, in colleges, in hospitals also. So in Tamil Nadu, Coimbatore plays a vital role in the name of the solar city. So this is the solar contribution of the solar energy in the power sector. Okay, here comes the masterpiece of wind energy generator. So we all know what is wind energy and how it is produced and all. So how the wind generators are equipped, how it is, how it functions, how it is basically built kind. So basically, we every one of us will think like only like electrical and electronic engineering plays the main role in the wind energy generators. Uh, of course, yes, but it also includes all the departments also. Like for example, if the civil department plays a vital role in in laying the foundation of the wind energy generators. So once the foundation is laid, then only every other things can be performed. And then mechanical department plays, it's like it covers 70% of topology, which means it 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 only does the every other thing, like basic things like equipping, welding, and shaping it. Everything is related to the mech. And then comes art department. Of course, yes, triple E is the core objective of generator, as we get the final output as electricity only because of the turbine, rotors, sorry, and the generators run. And then, okay, everything is done, right? So, civil department has laid the foundation, and mech has laid the manufacturing of the turbines and all, and triple E has given the excuse me, and Triple has given the generators and rotors, everything, so that we are getting the electricity. So everything is completed. Then why we need CSE, IT, and EC and all? Of course, it is also very important because the CSE plays an important role. Like it gives the architecture control and supervision area. Like if a turbine is in on wind farm, a person cannot monitor it often, like a full day, whole night. A single person cannot be in like how to cannot lead a single mission like that. We can't keep it. It has to be monitored regularly. The everything has to be in correct data thing. So in that way, the supervision area is given to the CSE. And then comes the IT. So IT is nothing but this gives the operation methodology and functional logics as algorithm. So this means we all know what is service call means. So for example, if we click something in some website, or some, if we take Google also, if we click something, we get the random suggestions down. So that is service call. If we click something like if we are searching for wind energy itself, so wind energy itself will have many suggestions like wind energy generators, wind energy turbines. So that is a service call basically made. So it comes within a fraction of milliseconds or microsecond. Within a second it comes, right? Sorry.
For me, it is showing first page.
Oh, okay. Only for you or everyone? For everyone, it is the first page.
That is what I have at
Yes. Yes, only first page is reading, Kausalya.
Okay.
This is-
Okay. Let me share my screen again.
It's okay, I thought.
Now you are in polar. Make it.
Okay. Okay. 1 second, sir. Is it visible now?
Yes, yes, yes.
Okay. Let me know if you can see this wind energy generators page.
No, solar energy in power sector.
Oh my God. Now?
Yeah, wind energy.
Now wind energy in generators.
Okay. So I'll present the screen in this mode itself. If I go in full screen, I think it is not coming. Okay. Okay, so as I was saying, the same thing. This is what I was saying. Like the IT plays a major role in giving the operational methodology and functional logics as algorithm. So it creates it monitors everything and it creates an algorithm kind. And then comes the ECE. The main advantage is like it is communicable remotely monitored. So as I said, a single person cannot monitor each and every turbines. It will be like it will be a high maintenance thing, so we can't do that also, like whole day whole night also. In that case, that supervision area is given to the CSE. So now they can be remotely monitored. The operational and functional data of wind generators can be remotely monitored, which is given to the ECE thing. So this is how all the combination of all the engineering departments combine together to form a wind energy generator. Okay. So we would have seen many of the wind turbines wherever in Tamil Nadu, wherever we go, we would have seen many of the wind turbines. But basically, all the wind turbines are white in color. So, what could be the reason, like why all the wind turbines are white in color? Some may be on the basically the conical shape, like how to say that tubular tower wind generators or white in color. So, why it is white in color? So, nothing so special, but still, if the wind turbines are white in color, means it gives a pleasant thing. It will avoid the unpleasant nature of the wind turbines. One, and then surprisingly, white paint can extend the lifespan of a wind turbine. So the white paint can also extend the lifespan of the wind turbine, it seems. And also, white paint of the wind turbines is eco-friendly. See, sometimes when the wind turbines, when the wind turbines are rotating, I mean the blades when the blades are rotating. Some birds may pass and they will not notice it and they may get hurt, like because of the rotor rotating and all. I mean the blades rotating and all. So in that case, in the dark, in the night times, if the wind turbines are rotating, means if it is in white in color, the birds may come to know like okay, something is revolving, the blades are revolving, so we should not move that way. So for that kind, they may keep the wind turbines painted as white. Mostly it is white only. Very rarely it is in other colors. That also very rare. But mostly we'll have a wind turbines white. And then now we'll see about the types of the wind turbines. So basically, there are three types. One is tubular steel, the other one is lattice, then the hybrid towers. The hybrid towers is nothing but the combination of the tubular and the lattice. What is that? Turbine. Okay. Um, Okay, so why it is tubular and lattice? Why there are these types in the case? So compared to the lattice towers, compared to it, the tubular profiles have an advantage of lower wind resistance. So in the tubular structure turbine, it have a lower wind resistance and it also have more aesthetic appearance. manufactured using a welded steel profiles. So the basic advantage of the lattice tower is the cost. The cost is low compared to the tubular steel. So tubular steel is high in cost, whereas lattice is low in cost. And the lattice tower require only half as much material for a freely standing tubular tower with similar stiffness. So, for example, if for a tubular steel, they are spending 1 crore to manufacture and to place it, means for lattice they'll only have to spend the half of the amount. So that is why there some may prefer lattice is better, some may prefer tubular better, but but according to that, how to see the long lifespan of the wind generators for everything, tubular steel would be better. Okay, and the steel hybrid towers is the combination of the tubular and the lattice. It may be on the onshore and also on the offshore. It is like in order to down, it will be like a lattice, and the upper part will be like a tubular steel. So in order to reduce the cost, the down it will be in the lattice, and in order to increase the strength up in the upper position, it is in the tubular steel kind. So these are the types of the wind turbine towers. The hybrid towers can be in the offshore and onshore also, anywhere also the same thing. The lattice is down and the tubular part is up. That is what. And then, okay. So here comes the basic wind energy thing. As we all know, like wind energy is the term. Wind energy itself, wind energy and wind power both describes like process by which the wind is used to generate the mechanical power or electricity kind. So as we can see in the image, the wind turbine turns the wind energy into electricity using an aerodynamic force from the rotor blades. So when the wind flows across the blade, air pressure on one side of the blade decreases. So the difference in the air pressure across the two sides of the blades create both lift and drag also. So the force of the lift is stronger than the drag, and this causes the rotor to spin. As the force of the lift is stronger than the drag, the rotor spins, and the rotor is connected to a generator, either directly or through a shaft. Okay, and this speed up the rotation and allow for a what can we say, the small generator. So this translation of the aerodynamic force to rotation of generator creates the electricity. So this is how the wind energy is getting produced, and we get electricity in that. So what are the types of generator? So basically, wind turbines contains these 4 generators, which is like induction generator, variable frequency drives, squirrel cage induction generator, doubly fed induction generator, permanent magnet synchronous generator. So these are the general induction generators which are placed inside the turbines. Okay, induction generator is nothing but a 3-phase rotational machine. They have stator winding arrangements, and they also produces 3-phase or a single-phase voltage output. That is what done by the induction generators. And then variable frequency drive. The variable frequency drive is it is a type of a motor controller which drives electric motor by varying the frequency and voltage of its power supply. So that is why we use a variable frequency drives, and this also have the capacity to control ramp up or ramp down of the motor during start or stop of the generator thing. And then comes the squirrel cage induction generator. This generator is very simple in construction and coupled to a turbine through a gearbox. It is very simple. It is just coupled to a turbine through a gearbox alone. And it is a constant speed generator, and the power control is aerodynamically by pitch yaw, and what can we, small active control is also is required in the squirrel cage induction generator. And then comes the doubly fed induction generator. It is a popular system in which power electronic interface controls the rotor, controls the rotor current to achieve the variable speed, which is necessary for maximum energy, which can be captured in the variable winds. So that is where the doubly fed induction generator works. And then comes the permanent magnetic synchronous motor. So it is more effective and efficient as compared to the other generator. So permanent magnetic motor is very effective and efficient also, and it has a high torque to size ratio, and it need less maintenance only, and omission of slip rings and reduced overall cost also. As this permanent magnet synchronous generator is very much efficient, but one major disadvantage of this is when the wind turbine, what to say, like, okay, the permanent magnet wind turbine synchronous generators with no control of the flux, it may attain to the peak. So it may cause any damage to the generators as well as to the motor. So these are the basic types of the generator. And if the grid fails, the generation gets failed. This is how it works. So onshore wind power refers to the turbine that are located. So onshore wind power in the sense that is located on the land, the wind turbines which are located on the land and which is used to generate the electricity. Here comes an offshore wind farm. Offshore wind farm is nothing but, if onshore is when the wind turbines are located in land kind, offshore is the wind turbines are located in the water bodies basically, and in the ocean or sea kind. So the working process of the offshore is also the same as the onshore wind turbines. But the thing is, in the onshore wind turbines, okay, we'll see in the next slide. Okay, this is how the offshore wind turbine looks. The force of the wind turns the blade, similar to the onshore itself. The blades are attached to a nozzle through a hub. The same thing, the same process, everything is same. The thing is, more wind energy can be converted into electricity in an offshore wind farm. Compared to onshore, the offshore wind farm generates more amount of the electricity. Okay, so here we can see the three things: onshore, offshore, and floating wind turbines. So basically, onshore wind turbines have the topography disturbs the wind flow. For example, if we are having wind turbines near farms or nearby the wind turbines, we have many. If we have many buildings, or if we have many industries and all, means the flow of the wind gets reduced. So because the all other buildings may how to say, buildings may avoid the flow of the wind flow to the turbine. So in order, like, in that case, the onshore wind turbines would become less in the production of the electricity. So this is a main disadvantage of the onshore wind turbines. So compared to onshore, in the offshore thing, if the wind turbines are mounted in the sea over 50 meters, so as of now, they have installed offshore wind turbines only to a depth of the 50 meters inside the ocean, and like, it can be 20, 30, up to 50, but more than 50 they haven't launched anything yet. This compared to the onshore, like in offshore, there is nothing, there is no buildings inside the ocean. We will not have any buildings. It is an open area, so wind flow will be very high. In daytime, the heat forms in the land, and the density of the air get decreased, and the volume increase. So the low weight air get moved fastly, and the high weight air also pushes the low weight. So the temperature also increases. So with offshore wind turbines, we can generate more amount of electricity. But the one disadvantage is, when it is high in cost, the maintenance is very high. Maintenance is also very high. And one more thing, if we are launching it in the ocean, means we should see in that particular area there should not be any passage of ships or any industrial thing, and it may also harm the aquatic animals also. So in that case, the offshore wind turbines have a disadvantage. And then comes the floating wind turbines. Floating wind, in the offshore wind turbines also, it is something fixed in the ocean. So it can generate the wind energy through only one direction. Like, if wind flows in one direction, it can generate in only in that direction. If in the night time or some other times the wind flows in the opposite direction, it can't get it also. Like only less amount of energy can be produced on when the wind flows in the opposite side. But whereas in floating wind generators, the wind turbines are laid like such as it will float in the ocean, so that where in wind can flow in the right direction or in the opposite direction, it will automatically gets rotated along the direction of the wind, and it takes the wind energy and it produces the what electricity. So basically, compared to onshore offshore, floating is very best to generate electricity. But the same thing, like cost is high, maintenance also high, and we should lay the wind turbines in which there should not be any other it will move, it will float in the turbines according to the wind. So it is very much how to say, like it need very much of maintenance and all. So it is something with these are the onshore, offshore, and floating wind turbines. Okay. Okay, here we can see in this image there is a land base, and land base which is nothing but the onshore, and then comes the shallow water which is the offshore. And these two are the proven technology, land based and shallow waters up to 30 meters. 30 meters they have proved, like we can keep it onshore in that land form, and we can keep it in the ocean also. We can